Now let us try to understand the Whitworth mechanism in detail and let us learn about its working as well. So fixed link is L minimum as we found in the previous discussion, and this is going to behave as a crank, that is AB will be a crank, even OB will also be behaving as a crank. Okay, so now the locus of point B with respect to A is going to be a circle. Okay, circle of larger radius. And next is the locus of point B with respect to O is also going to be a circle. What we do is the link OB is extended on another side up till the point C, and to the point C there is one more link that has been attached, and to that link a cutting tool has been connected. So now here it is visible that the link OC or OB is going to complete a circular motion. So you will be finding two different circles from two different centers. One is O and one is from A. So that is indicating the crank, that is link B is going to behave as a crank. Even the slotted bar is also going to behave as a crank. So this is the working of the Whitworth mechanism. You can see here two different positions, that is B1 and B2. So that we will understand in order to know the extreme positions of the cutting tool and how the cutting tool is going to cover up the distance. Now let us try to understand the working of Whitworth quick return mechanism. And during the working, we also will try to predict the positions of the link when the cutting tool is attaining the extreme positions. So here the quick return mechanism is used in the shaper and slotting machines. And here the point A is the fixed point about which the slider moves. The extension connects the ram and pivot end of the slotted bar. So this is the extension of slotted bar to which another link has been attached, and to that link the cutting tool or the ram is attached. The axis of motion of the ram is perpendicular to OA as it passes through O point. This will be axis of motion of the ram and it is perpendicular to OA, that is fixed link. Now let us try to understand the working of Whitworth mechanism. So this will be the fixed link. This is the point O and this is A. To this the slider is been attached. A is the crank or AB is the crank, and to this the slider has been attached. Through the slider a slotted bar is been assembled. So this will be the slotted bar, and the end of slotted bar, let's call it as C, and this is attached to the ram as well. Now here when the slider is moving to point B1, let's say the slider is moving to point B1, due to that the point C will move to new position C1. Both of these will be diametrically opposite. Both of these will be diametrically opposite. So now here when the point C1 is attained, the cutting tool is at left extreme position. Now the cutting tool is at left extreme position. So we have brought the tool to left extreme position, and the counterclockwise or anti-clockwise motion has been given. Due to this motion, the point B is following the path B1, B2. Let me change the color over here. It is going to follow a path B1, B2 in the counterclockwise sense. Let's say this is B2. This is the path followed by point B. Same way, the point C is going to follow the path C1, C and C2. This is where the point C2 will be. Even this is also going to move in the counterclockwise sense. So here the pivot is moving through the point C1, C, C2. So this C1 is going to tell us left extreme position, and this C2 will tell us about the right extreme position. So the distance between C1 and C2 is actually measure of stroke length. So here you can find the point C2 is here. Due to this, the cutting tool will move forward. Same way, if you consider point C, due to that, the cutting tool will be in the left extreme position. So this is nothing but measure of stroke length. Now, when the ram moves forward, during which the material is removed, so when the ram is moving forward, that is from left to right, due to that, you can see the slotted bar is covering the distance from C1 to C2. And you can see the crank is covering or undergoing the angular displacement from B1 to B2. Okay, so that is, this angle is going to tell you about the cutting stroke. Okay, so material is being removed, and at the end the slider takes the position B2. The cutting tool is at extreme right position, so it is already indicated in the diagram. So when the crank is at B2 position, the slotted bar will take a position C2, due to which the tool will move to the right extreme position. And the time taken for the forward stroke is angle alpha. So this is the angle for the forward stroke. Now here in the working principle, that is when the ram is moving forward, during which the material is being removed. So the forward movement of the ram is being marked by the motion of slotted bar from position C1 to C2. And here if you observe, the crank is moving from the position B1 to B2. Okay, so this angle is going to tell you about the forward stroke, and that is alpha. Okay, due to this, the cutting tool will be at extreme right position. Time taken for the forward stroke is proportional to angle alpha. Same way, when the slider is moving from B2, B3, B1, the rest of the circle, then the pivot is going to pass through the points C2, C3 and C1, and the ram is going to complete return stroke. So if I want to express that in the diagram, let me go back to the slide. So here, this was for the forward stroke. Now here, the crank, yellow color crank, will be moving along this path, and it will be coming end to point B. So B2, you could call it as B3 and B1. So during this motion, the ideal stroke or return stroke, that is going to happen. Same way, the slotted bar is going to move, or the path of the slotted bar will be indicated by green color. The slotted bar will be taking this path instead. That is, cutting tool is moving from the right extreme to left extreme during this path. That is B2, B3 and B1. Same way, that is for slotted bar, it is C2, C3 and C1. And the ram makes a return stroke, that is called as ideal stroke. No cutting is being performed. So time taken for the return stroke is beta, and the angle beta is smaller than alpha, because return stroke, here it is a word quick. So for return stroke, the time should be less. Time has to be less. Okay, and alpha has to be greater than beta. Alpha is responsible for cutting and beta is responsible for the return. So beta has to be smaller because the word itself indicate quick return. Return should be smaller. Return should be less. That means the time taken for the return stroke is less than the forward stroke. Hence it is known as quick return mechanism.